number 6.
Yes.
I could give you the numbers that I have if that works. Or maybe it would be easier for you to look at this one.
Oh, yeah. Yes, you said, of course, the precise definition, 2.4. Okay, yeah. And you said number 6?
Correct. The machinist.
6. Okay, so real manufacturer is a metal disc with the area of 500 square meters. Okay. What radius produces such a disc? Circular metal disc with an area. So the area is 500 centimeters squared. And since it's a disc, this is pi r squared. So first, oh, I'm sorry, you wanted me to use your number? I mean, it's probably a different number.
No, it's fine. It's mostly just like a refresher on like the whole precise definition, like doing the solving it, and then like the epsilon and delta.
Sure. So first of all, then I have r squared equals 500 over pi, and I have to take the square root, and I get r. I should put plus or minus, but it's a radius. I can't. So it's 500 over pi, and they want 4 decimal places. So the square root, you know me, I love my parentheses, 500 divided by pi, and close the parenthesis, and I got 12.6157. I shouldn't write it here. 12.6157 centimeters. And that's part A. Is part A okay?
Yes, it is.
Perfect. Okay, now let's move on to part B. In part B, it says an error of, so plus or minus 6 centimeters squared is the error. Okay. And in the area of the disk, so the error in the area because of the centimeters squared, of course. So the area of the disk, it has an error of 6 centimeters squared. So pi r squared, right, the area, minus the error, says must measure control the radius around your answer to 4 decimal places. Okay. So I'm just thinking for a second. This was in 2.4. Okay. So remember when we look at the limit, so let's say the limit of f of x as x approaches a is L. This is equivalent to, for every epsilon greater than 0, there exists a delta greater than 0 such that 0 less than x minus a less than delta. This will always imply f of x minus the limit in absolute value less than epsilon. So this is what we are really given. So we are told that the error is 6 centimeters. So the function is pi r squared minus the limit is less than 6. And we are asked to find, so what is the limit? The limit is 500. So we want the limit of this function to be exactly 500. We don't want any error, but we are told that epsilon is 6. So then we have to solve this inequality, which turns into this, and I have to solve for r. So once I solve this inequality for r, I will get something like this, whatever. And this is what they want. So if I want the area, the distance between the limit and the area, which I know is not 0, to be less than the error of 6 that they give us. In my problem they give 6, maybe in your problem they give 4 or 3 or something else, right? So then I want this to be less than 6. What should the tolerance on the radius be so that the area will not have an error more than 6 centimeters squared? So now I change this into this. Of course, I have to add 500 to both sides. So this is 506, and this is pi r squared, and this is 494. I have no choice. I have to divide by pi. So 494 over pi less than r squared less than 506 over pi. And now I will take the square root from this, the square root from this, and the square root from this. I always say, please don't take the square root from both sides or 3 sides of an inequality. However, if I have 2 less than x less than 4, I can, because everything is positive. Everything is positive here. So this side will be the square root of 494 over pi, and this one will be the square root of 506 over pi. This will be the smallest radius that I'm allowed to have, and this will be the largest radius that I'm allowed to have to guarantee that the error in the area is not more than 6 squared centimeters. I will take the square root. Square root 494 divided by pi, and the other one 506 divided by pi. Oops. What do they want? They want 4 decimal places. So I get, I see the inequality symbol, so that's what I'm going to write for the lower one. 12.5397. And for the upper one, 12.6911. And that was part B. A lot of work. A lot of work on part B. Okay, now part C. In terms of the epsilon delta definition, blah, 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 what is x? Of course, x is the radius. What is f of x? Of course, the area. What is A? Yes, it is the target radius. It's not the area, it's not the radius, it's not the target area, it's not the tolerance. What is L? Of course, the target area. Very nice problem. What value of epsilon is given? Of course, we discussed that. The epsilon, in my case, is 6. Of course, centimeters squared. What is the corresponding value of delta? Oops, I haven't calculated delta yet. Okay, where is my radius? On my previous page, where is the radius? Okay. So I'll determine this difference. And what do I choose? remember how we make a decision. So 12.6157 minus 12.5397. I got 0.076, and now this will be 12.6911 minus 12.6157, and I got 0.0754. How do I make a decision on delta? Delta is the difference between A, which is this, and A plus delta, and A plus delta. A plus delta, A minus delta. So how do I choose? Okay, let me draw the graph. So here is R, 12.6157. This value is here, and this value is here. Do I choose this as delta, or do I choose this as delta?
Did you move up the paper?
Oh yes, I'm sorry.
Don't you pick the one that's closest to...
The smallest delta. Excellent. Because this is 0.0754, but this, I know I exaggerated, is this. What's the difference? Tiny, right? But still, this is larger, and I cannot use it. This is smaller, and I have to. Very nice question, very nice problem. Well done.
By any chance, do you know what section the squeeze theorem is from?
The squeeze theorem is in limits, chapter 2. The squeeze theorem should be into limit of a function, 2.2, pretty sure.
I have a question.
Yes, please.
It's from section 2.5,
Okay.
and I can give it to you.
Yes.
So suppose f and g are continuous functions such that g of 3 equals 5, and the limit x approaches 3, and it does a bracket 3 f of x plus f of x g of x equals 40. Find f of 3. Yes.
Good. So we're told that they are continuous functions, which means they don't have gaps, they're not undefined anywhere. So the limit of whatever this is allows me, I'm allowed to use limit laws. Once I'm told that, there's no problem, there's no infinity, no gaps, no holes in the graph. So the limit of whatever, I can apply limit laws. And I will do that. So the limit of this will be 3, limit f of x as x approaches 3. The limit of this, so plus, limit of f of x as x approaches 3 times limit of g of x as x approaches 3, and all this equals 40. Now let's stop for a moment and see if we have questions. So the limit of a function times a constant, I put the constant in front, limit of the function, plus the limit of a product by limit law allows me to write the limit of f of x times the limit of g of x, because they are continuous. And these limits exist. For any continuous function, there is no gap, there is no undefined situation, there is no DNE, the limits all exist. Okay. We are told that g of 3 is 5. So when we apply for a continuous function, when we apply the limit when x approaches 3 of g of this, so this must be 5. So I will factor out limit of f of x when x approaches 3 from these two products. Open a bracket, I have a 3 in front, and plus this is 5. So all this is multiplied by 3 plus 5, so this is 40. But 3 plus 5 is 8, and I will divide both sides by 8. So then I have the limit of f of x as x approaches 3, 40 divided by 8, because I have to add first. 40 divided by 8 is 5. So now, what could f of 3 be if I know that f of 3 is a continuous function, and the limit as x approaches 3 from either side is 5 from a continuous function? So this must be anyone? So if this is a continuous function and the limit is 5, then f of 3 must be 5. Because it's a continuous function. Remember, the limit from the left and the limit from the right and the function value have to be the same. It's a continuity at a point. So limit as x approaches 3 from the left of f of x must equal limit of f of x as x approaches 3 from the right, and must equal f of 3, because the function is continuous at x equals 3. So then all these have to equal 5. Otherwise the function will not be continuous at 3. Very good question. Awesome.